Download this code from codegive.com, link in the description below. Mastering HTTP 500 Internal Server Errors, a complete guide. The dreaded HTTP 500 internal server error. It's the bane of developers everywhere, a cryptic message that offers little insight into the underlying problem. This comprehensive tutorial will delve deep into understanding, diagnosing, and resolving 500 errors, equipping you with the skills to handle them effectively. Understanding the 500 error asterisk. The HTTP 500 status code signifies that the server encountered an unexpected condition that prevented it from fulfilling the request. This is a generic error, meaning it doesn't pinpoint the exact cause. The problem could stem from various sources within the server's infrastructure or application logic. The lack of specificity is precisely why effective debugging is crucial. 2. Common causes of 500 errors ***. Several factors can trigger a 500 error. Let's examine the most frequent culprits. Code errors ***. This is the most common cause. Bugs in your server-side code, example syntax errors, runtime exceptions, logic flaws, can lead to unexpected crashes or failures. These errors can occur in any language used for backend development: Python, PHP, Node.js, Java, Ruby, etc. Database issues problems with your database, example connection failures, query errors, deadlocks, will often manifest as 500 errors. Incorrect database configurations, insufficient permissions, or poorly written queries are frequent offenders. Server configuration problems incorrect server settings, example missing modules, incorrect permissions, resource exhaustion, can prevent your application from functioning correctly. File system issues problems with the server's file system, such as insufficient disk space, permission issues, or corrupted files, can also lead to 500 errors. Third-party library errors bugs or compatibility issues within external libraries or APIs your application relies upon can trigger errors. Resource exhaustion if your server is overloaded, high CPU usage, memory leaks, or running out of available connections, it might fail to handle requests, resulting in a 500 error. Security vulnerabilities in some cases, attempts to exploit security vulnerabilities might cause the server to crash and return a 500 error, though often a custom error page might be implemented for better security. 3. Debugging and troubleshooting techniques Effective debugging requires a systematic approach. Here's a breakdown of essential steps. 1. Check server logs This is your first and most crucial step. Server logs, example Apache error logs, Nginx error logs, application logs, contain valuable information about the error, including timestamps, error messages, stack traces, and potentially the specific line of code that caused the issue. The location of these logs varies depending on your server and application setup. 2. Enable detailed error reporting, development environments. In development or staging environments, enable detailed error reporting to get more comprehensive information about the error. This might involve configuring your web server or application framework to display stack traces and other debugging information. Never do this in production. 3. Disable caching Browser and server-side caching can sometimes mask the underlying problem. Clearing your browser cache and disabling caching mechanisms on the server can help reveal the true cause. 4. Simplify the request If the error occurs only with specific requests, try simplifying the request, example removing parameters, changing data, to isolate the problem. 5. Test with different browsers and devices. In rare cases, the issue might be related to browser compatibility or device limitations. Testing on different platforms helps rule out client-side problems. 6. Inspect network traffic. Use developer tools, example browser's network tab, to analyze the HTTP requests and responses. Look for unexpected responses or errors in the request/response cycle. 7. Reproduce the error. Try to consistently reproduce the error. This makes debugging much easier. Detailed steps for reproduction are essential for reporting the issue to others or searching for solutions online. 8. Use a debugger. Utilize a debugger, example PDB for Python, stdebug for PHP, to step through your code line by line and identify the precise location of the error. This is incredibly effective for pinpointing code-level bugs. 9. Check server resources. Monitor server resource usage, CPU, memory, disk space, network, to see if there are resource exhaustion issues. Tools like Top, Linux/Mac OS, or Task Manager, Windows, can provide this information. 10. Check database connections and queries. Verify that your application can successfully connect to the database and that your database queries are correct and efficient. Look for database errors in the logs. 11. Examine third-party libraries. If you suspect an issue with a third-party library, check for updates, known bugs, or compatibility problems. 4. Code example, illustrative Python with Flask. This example demonstrates a 500 error scenario and how to handle it gracefully. Template/index.html. Template/error.html. This example demonstrates exception handling in Python/Flask. In a real-world scenario, you'd likely log detailed information using a structured logging library. The applogger.exception call is essential for capturing the full stack trace for debugging purposes. Production error handling *. In a production environment, never expose detailed error messages directly to users. Instead, implement robust error handling to gracefully manage exceptions. 1. Custom error pages *. Create custom error pages, example of 500 internal server error page, that provide a user-friendly message without revealing sensitive information. 2. Centralized error logging *. Implement a centralized logging system to collect and monitor all errors. Tools like ElkStack, Elasticsearch, Logstash, Kibana, Graylog, or dedicated logging services can help. 3. Error monitoring *. Use error monitoring services, example Sentry, Rollbar, Bugsnag, to track and receive alerts about errors. These tools often provide detailed error reports and help identify recurring issues. 4. Automated alerts *. Set up alerts to notify your team immediately when critical errors occur. 6. Conclusion ****. Mastering 500 errors requires a combination of understanding potential causes, implementing effective debugging strategies, and employing robust error handling in production. By following the techniques outlined in this tutorial, you'll be well equipped to diagnose and resolve these frustrating but common server-side problems. Remember that thorough logging and proactive monitoring are your best defenses against production issues.